Now we're going to actually wrap up the virtual alias maps section by adding support for additional domains. Let's actually take a look at our virtual file. It currently is routing messages for linuxcbt suzy1 at linuxcbt.external, as well as dean at linuxcbt.external, as well as a catch-all address which maps to both local users. But what if we wanted to add additional domains? What if you're in a corporate environment, you've just purchased an additional domain that you'd like to route email for? Well, simply put, what you do is modify the main.cf file, navigate to the area where we've defined our virtual alias domains, and append the new domain. Just use a delimiter such as comma and or space, which are both supported by postfix. So let's say we have an additional domain. Let's go with Linux computer-based training, which is the full expansion of CBT, .external, new domain. Looks similar, but it's totally a new domain. Remember, computers are precise, so one does not equate to the other. It doesn't auto-expand CBT. So this is a new domain that we'd like to provision support for. So far so good. We've made a change to the main.cf. We'll save it, and before restarting postfix, we should then update our maps file. We'll modify virtual, and we need to provision accounts in this file. Now again, this virtual file can also be defined in other repositories such as MySQL databases, LDAP, and so on, but it's a good idea to get it working in a flat ASCII two-dimensional matrix represented form, such as the file that we're working with. Great. So we have support for the other domain. Again, remember, you can add comments, so perhaps you want to put some space in here and say support for, or perhaps something such as linuxcbt.external domain, and in a separate area you set up Linux computer-based training.external domain to separate the two. So beneath, we'll define mappings for Linux computer-based training.external. So what addresses would we like to handle? Let's treat this like an official production mapping where we need to set up certain addresses that virtually all companies have. Let's begin with sales at Linux computer-based training.external is equivalent to a local user or a remote user. Of course, we'll begin with a local user because the assumption is that the users are picking up their emails from the local system. But of course, we could be relaying this to a totally different system. In other words, our postfix system that's currently implemented could just be a front-end box out in the DMZ which accepts messages from the internet, but really translates them to a different domain on the inside. Maybe your internal server accepts messages destined to .internal or some other domain. So sales at Linux computer-based training.external can be routed into Linux CBT suzy1's mailbox. Let's define one also for info at Linux computer-based training.external, and we'll send info-related messages into Linux CBT suzy1's box. Let's define one for abuse at Linux computer-based training.external, and this will be sent to Linux CBT suzy1's box. So abuse, info, and sales will be routed into. In fact, let's change abuse. We'll send abuse, that is. Let's send this to root's box. We'll send some messages to root. Then we can create a user called Dean at Linux computer-based training.external, and we'll send it to the user Dean's box. Now perhaps you want a catch-all just like we've defined, or maybe you don't. So let's work with what we have. We have sales, info, and it says info T, sales, info, abuse, and Dean. There currently isn't one for Linux CBT suzy1. We'll save it, postmap virtual. And by the way, you can query addresses from your virtual database, so you can execute such as the following. Use postmap q to grep a name such as abuse at Linux computer-based training.external from the virtual file, and it returns who, or the right-hand side, who would actually receive the message. Let's try that for a different address, such as sales. Linux CBT SUSE1 would actually get the message, or receive the message. Let's try Dean, and the local user Dean would accept the message. Let's actually add another mapping. Let's create one. We'll say public at Linux computer base training.external will be routed to Linux CBT SUSE1 at Linux computer base training.com. So we're just defining these basic mappings, two-dimensional matrix style. So if a message is destined to public, that is, it'll be sent to the internet user. Let's postmap virtual, and we'll execute a postmap-q public at Linux computer base training.external, which will get mapped out to .com. And we need to grep this from the virtual file, and it maps out to .com. Great. So now that our infrastructure is in place, let's do a postconf grep virtual alias underscore, and you'll see that our domains, we have this new domain. So now we need to go off sending messages to this new domain. But there's a problem. If we attempt to send a message from Linux CBT work1 to some user at Linux computer base training.external, unless DNS is properly set up, Linux CBT work1 will choke. It'll perform an MX lookup, it'll fail, and not be able to deliver the message. It'll bounce. Let's try that. We'll send a message to abuse at Linux computer base training.external testing domain that isn't set up in DNS or transport table. We'll send it. Now it doesn't immediately give us the bounce, but if we were to examine tail var log mail on the SUSE professional system, we'll see that it's unable to deliver the message. Host not found. It can't find the host, which is exactly what should be returned. So it'll bounce the message, but we currently have restrictions, so it's not sending the message back to our account. So that tells us we need to do a few things, or one of two possible solutions here. We need to either set up a DNS infrastructure which maps to Linux computer base training.external, so in other words, set up a zone, or to make life easy, define a transport table. If we have a transport table defined and in use, this is the default file that's currently not in use, but if we do have one that's in use, then the local postfix instance will know how to route messages destined to a domain called Linux computer base training.external. But this is a one-off fix. This fix applies to this system and for any host who uses this particular box as a relay. It's a fix in that case. But for internet use or for relaying in an environment where DNS is necessary, this is not the proper fix. The proper fix is to set up DNS zone. Great. A postconf, since this is a one-off patch, and a grep of transport underscore maps will reveal what maps are currently defined. Currently nothing's defined. So we need to update this setting on the SUSE professional box. So that's nano main.cf. And since it's undefined, it's probably not even specified. Let's search for it anyway. And it isn't. So towards the bottom, we're going to create a new entry. Transport underscore maps is equal to hash etc postfix transport. And we'll just add a comment added for one-off support or routing of messages to Linux computer base training.external. Super. So we have the directive in here. Now what we need to do is actually make the changes to the transport file. So if we nano transport, you'll see it gives examples of how to define your transports. And if you follow the table format, you'll see that it follows pattern, then result. So whatever left-hand side will result on the right-hand side. And we've shown you in the transport section how you go about doing this. So we'll specify a domain, which is Linux computer-based training.external, which will be followed by SMTP and the next hop. Let's go off doing that. The domain is Linux computer-based training.external, followed by a tab, and we're going to use a transport SMTP to deliver the message, followed by no MX lookup because we want to expedite delivery, and we'll use the host linuxcbt suzyserve1.linuxcbt.internal. Now, we're using this particular domain because it's already set up in DNS. We could also specify the IP address here, but it's typically safer to specify DNS names in the event that an IP address changes. DNS can map it out for us. So one level of abstraction. So now we have a transport setting which says any messages destined to Linux computer-based training.external, dump it to SMTP linuxcbt suzyserve1.linuxcbt.internal. So use that system as a relay. We'll execute postmap against a transport file to generate a DB version of the file. We now have that DB version of the file which can be queried. We can query the left-hand side using postmap-q. Now let's restart postfix using postfix reload. We'll tail varlog mail just to see any evidence of trouble or problems interpreting any of the directives that we've specified. It says local mail is disabled, so currently local mail is turned off. In fact, you can grep local or use postconf from main.cf and you'll see where the directives are. It's currently turned off, local_transport, which is why any of the bounces are not coming back to the system. If you'd like to re-enable local mailing, simply get rid of the entry here that says local_transport equals error and so on. But nonetheless, our system now knows how to route messages based on the transport table. So let's launch mutt, compose a new message destined to abuse at Linux computer-based training.external. Testing virtual alias map using local transport table for routing. We'll send it, and then we'll examine our local varlog mail to see what's going on. As you can see, our system, our postfix, our local postfix on the SUSY Pro system has used linuxcbt suzyserve1.linuxcbt.internal to relay the message, and we returned or received an exit status of sent from the remote system. So the message was delivered. It's not in our queue anymore, which means in the first shell we should be able to see positive results in varlog mail, and those positive results should reflect that the message destined to abuse was delivered to the user root. Because again, in our virtual file, any message destined to the user abuse should be rerouted to the user root. So now if we launch mutt, we'll see the message, testing virtual alias map using local transport. There it is. The message came into abuse. We got it. So I think you get the picture. So we've used a transport table to patch our situation here. But again, if you intend to rely upon DNS MX resolution, then just ensure that your DNS infrastructure is set up properly. Define the DNS zone so that resolution can take place. If not, transport maps are always a great way to force messages that match a certain left-hand side to end up at a certain server. Great. Next, we're going to look at some other things that we can do with virtual domains. There's so many things we can do using this technology with many of the MTAs, but postfix makes it pretty straightforward, so we're going to focus a little bit more on that coming up.